One thing I kind of skipped over that I wanted to talk about is going to be the oxyhemoglobin dissociation curve and how that's going to tie into everything. Um, the point of this curve is going to measure the concentration of O2 saturation of hemoglobin compared to the tissue. When we're at the lungs, we are going to be at the highest point. That is where we are at 100. It's going to be the highest point of concentration of oxygen on hemoglobin, because that is where oxygen is binding to hemoglobin as soon as it leaves the lungs, and as soon as it comes out of the heart, as soon as it gets to the aorta, that oxygen is going to be dissolving in acid, and that is going to allow the oxygen to flow into whatever muscle we need it to, lowering the concentration of oxygen, which in then turn lowers the oxyhemoglobin dissociation curve. So when we're talking about things like, for example, biking, it's going to be mainly lower half body movement. It's going to be our quads, calves, all those muscles down there. That's what's going to need the oxygen. That's what's going to need our blood flow. So we're going to vasoconstrict on the upper half of the body, vasodilate on the lower half of the body. That blood that is now oxygenated, which came from the highest concentration of oxygen in the body, which is the lungs, is going to go through the aorta, arteries, arterioles. It's got the capillaries. Now we're at the capillaries of the blood. That O2 is then going to mix with hydrogen ions that we've accumulated and has been shot through the NHE channels and the MCT channels. That oxygen is going to mix with those free hydrogen ions, which is going to dissolve the hemoglobin, which allows allows oxygen to go into the muscle, giving us the muscle we need. In that turn, we are losing that oxygen from the hemoglobin from the red blood cells, in turn lowering the oxyhemoglobin dissociation curve. Once we get through the veins, we are going to be towards the very bottom until we get all the way back into the heart, back into the lungs, where we get back to the top.